f of x is equal to x squared plus 5 over 2x minus 3x minus 1. Part A, use differentiation to find f dash x. So first things first, in order for me to differentiate f of x, I need to write it in a form that can be differentiated. So that 5 over 2x, I'm going to rewrite that as 5 over 2 multiplied by x to the power minus 1. Then I've got the minus 3x and the minus 1. I can now differentiate each of these terms easily to get 2x minus 5 over 2 x to the power minus 2 minus 1. The only other thing I'm going to do here, because I know I'm going to use this to substitute a number in a minute, I'm going to rewrite that x to the power minus 2 back in its regular form like this to make it easier for me to substitute numbers into. You don't have to. This is a good answer for part A, but like I say, this is more useful for substituting numbers into. Okay, the root alpha of the equation f of x equals 0 lies in the interval between 0.7 and 0.9. It says, taking 0.8 as a first approximation for alpha, apply the Newton-Raphson process once to f of x to obtain a second approximation for alpha, given my answer to 3 decimal places. This is the formula for Newton-Raphson. You do get given this in the formula booklet. So our first approximation is 0.8, so that's our x0 if you like. We've already got our function, f of x here. We've already got our gradient function that we worked out in part A. So we can use the Newton-Raphson process. So x1 is going to equal 0.8, our x0, minus f of 0.8 divided by f dash of 0.8. So f of 0.8, this is me substituting 0.8 into my original function. F dash of 0.8, that's me substituting 0.8 into my gradient function. So let's see what happens when we do that. When I substitute 0.8 into the original function, so 0.8 squared plus 5 over 2 times 0.8 minus 3 times 0.8 minus the 1 gives 0.365. Now we need to substitute 0.8 into our gradient function. So again, let me do that. 2 times 0.8 minus 5 over 2 times 0.8 squared minus the 3. And we get minus 5.3062. So putting all that into my calculator then, 0.8 minus the 0.365 divided by the minus 5.30625, and I get 0.869 to 3 decimal places, and that is my second approximation for the root of that equation.